Good morning. This is Ms. Billerbeck, and we're going to talk about 4.2, solving quadratic equations by factorization. So the factorization method uses the following property of real numbers. So remember, real numbers are not imaginary. So imaginary numbers happen when we have like the square root of 1. It's not real. So we have the imaginary number I that we use for the square root of 1. All right, so you're not going to see that for a very long time. So let's just pretend that all numbers are real. Okay, so actually, well, now you know they aren't all real, but let's just pretend for now. Okay, so for any two real numbers, P and Q, if P times Q equals 0, then either P equals 0 and or Q equals 0. Okay, so they could both be 0, P could be 0, or Q could be 0. Okay, so that's really important when we try to solve this equation. Now, we have an equal sign now, which makes it an equation. All right, so now let's factor this using our diamond box. We have A, B, D. And now the important thing is we ordered this in the highest degree to the lowest degree. That means this exponent here is 2. This is a 1. We don't write 1. Okay, but there's really a 1 there. And we don't write x to the 0 either, because x to the 0 equals 1. So we just don't write that one. So let's erase that right now. We're going to erase this too. Okay, so this is ordered from highest degree to lowest degree. All right, so we have A times -1. Don't forget that negative. That's going to be important. Okay, so we have -15 here, and B is 2. So we know that there's two terms. One is negative, one is positive, and they're 2 apart. So 3 times 5 equals 15. So that would make that -3 and 5. Because -3 times 5 is -15, and -3 plus 5 is +2. So now let's go and do the box. Okay, so we have 15x squared here. We have -1 here, -3x, and 5x here. These don't have much in common except 1. Then this one, oh, look at that. They have 3x right here. So 3x plus 1 on the top. This 15x squared and 5x have 5x as the greatest common factor. And -3x and -1, well, they have a -1 in common because they're both negative. So this factors as 3x plus 1 times 5x minus 1 equals 0. All right, so we can quickly check that. 3x times 5x is 15x, and then 3x times -1 is -3x. And we have a 5x. 5x plus -3x is 2x, and 1 times -1 is -1. Okay, so using this rule that if P times Q equals 0, just like this, then that means one of these is 0. So one or both. So we have 3x plus 1 equals 0. And we can skip the old parentheses at this point. Okay, so 3x plus 1 equals 0, or we have 5x minus 1 equals 0. So now we can solve and find out, well, what is x? So we're going to use an additive inverse and move that over there, that 1. So we get 3x equals -1. Now I want to get this 3 away from the x, so I'm going to use the multiplicative inverse and divide by 3. So we get x equals -1/3. All right, so we have one solution. Now let's use an additive inverse and move that one over here. We have 5x equals +1. We use a multiplicative inverse and divide by 5 since 5 is multiplying with the x. And we get x equals 1/5. So our solutions for this problem, and we can write solutions in fancy little tildes like this, are -1/3 and 1/5. Okay, so if we put -1/3 in here, -1/3 times 3 is -1. -1 plus 1 is 0. 1/5 times 5 is 1. 1 minus 1 is 0. So there we go. Now, when it's a real situation, we can check and see, do these numbers make sense? But right now, we are just using theoretical equations. So we're going to list them both as solutions. When it's not a real solution, we call it an extraneous solution. All right. So sometimes we get extraneous solutions just mean that it doesn't fit the model that we have. Like, say we are doing a time problem, and when we end up getting a time equals a negative number, well, that's not possible. We can't go back in time. So that would be called an extraneous solution. All right, so if we do some distribution here, we have 3x times 3x is 9x squared. And then 3x times 14 is plus, that is 3 times 4 is 12, so that's 42x equals -49. Okay, so we need to add this 49 to the other side. And what that gives us is 9x squared plus 42x minus 49. Oops, sorry, that's a plus 49 equals 0. Oh, look at that. This is a special product because I was kind of clued in that 49 is 7 squared and that's a 3 squared. So a 3 squared x squared plus 2 times 3x, and we have a plus 7 squared equals 0. So this is times 7. That's that missing one. So 3 times 2 is 6, times 7 is 42. So this is called a special product of a perfect square trinomial. So this gives us 3x plus 7 squared equals 0. There we go. So now we just set that, we just need to set one of them to 0. So 3x plus 7 equals 0 since it's the same thing. We move the 7 over to the other side using an additive inverse. 3x equals -7. We have 3 multiplying with x, so the opposite of multiplication is division, so we use a multiplicative inverse of 3. And we have x equals -7/3. And that is our solution. And then we could use those fancy little tilde signs like this and write the solution like this as well. All right. So now let's look at this. This involves a lot of distribution. So we're going to distribute like that. So we have 3x times 5 is 15x. 3x times -x is -3x squared. That's going to equal 2 times 7 is 14. And 2 times -4x is -8x. All right, I probably want to move all this to the other side. So I am going to add this 3x squared to this side. Okay, so I have 15x. I use the multiplicative inverse. Sorry, not multiplicative. The additive inverse of 3x squared. Okay, equals. And then I'm just going to have 3x squared. I'm going to keep the negative 8x right with that and then add the 14 like that. So we're going from least to greatest as far as highest degree to the lowest degree. Now we still have to move this 15 to the other side using an additive inverse. Okay, so we end up now with 0 equals 3x squared. This, when they're both negative, we're adding to our negative. So we have minus 23x plus 14. That's an unusual combination, don't you think? All right, well, let's see what the diamond box creates. So we have 3 times 14. So that gives us 42 again, and negative 23. All right, so we have to figure out somehow how to make negative 43 and make sure we didn't do anything wrong with the signs, and we did not. Okay, so, all right, so let's use this little factoring thing. This one is a little unusual. So times 40 adds to 42. Times, when you multiply the two numbers, it multiplies to be 42. When you add it, it is negative 23. All right, so they're pretty far apart. So, oh, I see what it is. Okay, so we know they're both negative because it makes a negative number, and then negative 2 times negative 21, and that's negative 23. There we have it. Okay, so we have negative 2 and negative 21. All right, so now we're going to use our box. So we put our first term 3x squared here, our last term 14 here. Oh, and when it's a negative times a negative, I have a new technique to add to the very popular technique, but I always had trouble with this. So let's put negative negative here, making a positive 14. So we know we have a negative to get to this column and a negative to get to that column. Okay, so negative 2, we have negative 2x. Negative 21 is negative 21x. So now there's no question that we have a negative to give to here. So then we just look for the common factor. That common factor between 21 and 14 is 7. And then this common factor here between 3x squared and 2x is just x. Here we have 3x. And then here negative 2x and negative 14 is just negative 2. So we see that this factors, let's go up higher here. So we have x minus 7, 3x minus 2 equals 0. All right, so what that means is I have x minus 7 equals 0. And when I use an additive inverse, that's a quick solution of x equals 7. And when I say 3x minus 2 equals 0, using the additive inverse of 2, I have 3x equals 2. Divide by 3, which is the multiplicative inverse of multiplying by 3, and I get x equals 2/3. So my solution for this is 2/3, 7. All right, so 2/3 and 7 would make both of these zero out. All right, so let's see, I have more problems. I'm a math teacher. I have so many problems. Okay. All right, so when I have something like this could be solved in a few ways. So let's try it. Okay, first of all, let's subtract the whole expression, x minus 4, x plus 3, to this side, minus x minus 4 times x plus 3. And what that gives us is x minus 4 times 2x plus 7 minus x minus 4 times x plus 3 equals, and this minus that is just 0. All right, then we see, oh look, they both have an x minus 4. That's a common factor. So we can take x minus 4 out and group what's left. So then in this big thing, we have 2x plus 7 minus, and that'd be x plus 3. Okay, note that this is a minus in front of a grouping symbol, so we do have to distribute the negative to both, and that equals 0, by the way. So we have x minus 4, and now we have 2x plus 7 minus x minus 3 in this parentheses. So once we simplify this, we'll have our answer. So we have x minus 4, 2x minus x is x, 7 minus 3 is plus 4, equals 0. Well, look at that. So if we do x minus 4 equals 0, let me make some room for both of these sides since we're running out of. So x minus 4 equals 0. We add 4 to both sides, and that gives me x equals 4. When I have x plus 4 equals 0, I subtract 4 from both sides, and I get x equals negative 4. So my solution, I'll put the solution right here, is very simple. Well, I'll write it in two ways, because you can write it in the easy way or in the really cool way. So this is the easy way to write it, negative 4, 4, or the cool way is this, plus or minus 4. There you go. So if you write it like this, math teachers will go, ooh, somebody knows what they're doing. All right. Remember, math is a language. You want to speak in a sophisticated way. All right. So let's do the same thing here. Let's just subtract this x minus 7 squared from this side. All right. So when we do that, I'm going to start writing over here. So we have 4 times 3x plus 1 squared. And then that's minus x minus 7 squared. And then we have equals, that's just 0. But wait a second, this is called a difference of squares. It's one of those special products. Okay, so this could be written 4 is 2 squared. So I could just write that as 2 squared right here, and then it's really a difference of squares. Okay, so that means what I would have is I better put brackets. This is going to get a little complicated. Okay, so I have 2 times 3x plus 1. And remember, we have plus or minus. So we take the squares off of these. Okay, see how I just took the squares off? So I'm going to add x minus 7 right here. Okay, so that's one bracket. But then I take the same thing, 2 times 3x plus 1, and instead of a plus sign, I use the minus sign. And then I have x minus 7 here. Pretty crazy, huh? Singapore math, they really like to make it complicated, but it's a very interesting approach. All right, let's simplify what we have in the parentheses and see what's hiding. So we're going to distribute that, then we're going to distribute this, and then we're going to distribute this negative to both of them. All right, so we won't need brackets after the distribution. So 2 times 3x is 6x. 2 times 1 is plus 2, plus x minus 7. And then we have 6x plus 1 minus x, and minus times a minus is a plus 7. So don't make the mistake of not distributing that negative to the second term. That's the number one mistake. All right, so I have 6x plus, and there's a 1x there, and there's a 1 right there. So 6x plus 1x is 7x. 2 minus 7 is negative 5. Then 6x minus 1x is 5x. And 1 plus 7 is 8. Ah, that's way to be complicated there. Okay, so we have 7x minus 5 equals 0. So I'm going to use an additive inverse here of 5, positive 5. And I get 7x equals 5. I'm going to use a multiplicative inverse of 7, dividing by 7. So I get x equals 5 sevenths. All right, so the next one is 5x plus 8 equals 0. I'm going to subtract 8 from both sides. And I have 5x equals negative 8. Then I'm going to use a multiplicative inverse of 5 and cancel the 5's here, so I get x equals negative 8 fifths. So my solution for this is going to be negative 8 over 5, comma 5 sevenths, or if we wanted to put that into proper form, we could write negative 1 3/5, 5 sevenths, like that. Okay, so that is finally my final problem for section 4.2. So I hope you enjoyed all this lovely complexity, and good luck with this. Have a wonderful day. Bye-bye.